9. Okay, Macaulay method. So Macaulay method, we have to use this method, or they have to derive this method, or they have invented this method because of problem when you have to split into different segments. In example 1, for the uniformly distributed load, we don't need Macaulay method. But in example 2, you have to split into 2 segments. In example 2, okay. Example 3, in the previous example, this one previous example, sorry. Okay. Okay. In this previous example, we need to split into 2 segments. So when you split into 2 segments, you have to integrate or develop 2 equations. If you split into 3 or 4 segments, for example, 4 segments, you need to develop 4 equations. But in Macaulay's method, you can just use 1 equation. We call it continuous equation. So this is the what you call it continuous function. This is mathematical definition. Okay. I don't have to explain this mathematical. We just use, or we go straight to the example. Example. Because if we explain the mathematical, we need to go to mathematics class. It's not our scope. Okay. Repeat example 1 with using Macaulay's method. Example 1. Example 1 is the one with the loading at B. Okay. Now, as we saw just now, the problem, we have to split into 2 segments A, B, and B, C. Okay. Now, in this Macaulay method, we can develop or derive one formula for all segments by consider a point at the last loading. Last loading here. Okay. First loading. If you have another loading here, you go to the last loading or last segment which has passed all the loading left hand side. That means you include all the loading left hand side. You start from left. So in this case, you derive a moment equation in between B and C. A and B cannot. In between B and C, where you have covered all the, in this case, only one loading. Okay, so this is the formula. Mx equal to 12x minus 18x. 18 x minus 2. You know this one? What is this? This is not bracket. Here. Here, this one. We use this symbol. What's mean by this symbol? We can see later. Okay. So this is the moment equation. 12x minus 18 multiplied by x minus 2. Why? Yeah. Why the difference? You have only 12x. Or we can say, if in this bracket the value is negative, we neglect this one. If in this bracket, if we neglect the second term, yeah, two term here, the second term we neglect. Can you understand? Yeah, because because the second term for x less greater than 2. That's mean by this sign, bracket sign. I repeat, whenever the value or the sum of x minus 2 is negative in this bracket, neglect this one. I have to repeat because normally in previous years, many of you didn't understand or forget where yeah uh, even though it is negative, yeah, you include in this equation and then your answer is totally wrong. Okay, so remember when x minus 2 or in this bracket this the sum is negative, neglect this term. Okay, so now slope equation is integration of m. Yeah, integration of m. Yeah, uh, deflection. Sorry. This one is actually moment slope deflection. Okay. Okay. So for the slope equation, integrate 12x as usual, normal integration, no difference. But in this case, where you have bracket here, the continuous function, you just integrate this bracket, not by yeah, x and 2, cannot. Just integrate this bracket as a variable. You can say it is easier, is it? It is easier. In normal integration or in normal bracket function, you have to what? You have to split 18x minus 9, yeah, and then 18x squared over 2 minus 9 x. Yeah, but in this continuous function, you just integrate x minus 2 as a variable. As a variable. Okay. And proceed. This one is deflection. Yeah. Again, integrate this one as a variable. Yeah. So becomes 3, and this one 3 here. 3 minus 2 as 3 multiplied by 2, 6. And this is as usual. The only difference here is when there is a function, continuous function. Then this is the EIY. Okay, can you understand? It is easier, yeah, easier than the usual integration. Okay, now you have C1, C2, two constant or unknown. So you need two boundary condition. What is the boundary condition? What are the boundary condition? Similar to what in previous uh, calculation, you have two boundary condition, x0, y0 here, and x equal to 6 meter, y equal to 0 here. Yeah, this one is boundary condition. X0, y0, x6, y equal to 6. Yeah, here. At x equal to 0, this is deflection equation. Yeah, you will find that C2 is equal to 0. Okay, again, remember, again, uh, be careful here. Whenever in this bracket, the sum is negative, neglect this one. Okay, I repeat, whenever in this bracket, functional continuous function is negative, neglect this one. So what you have, 0 plus 0 plus C2 equal to 0. Therefore, C2 is equal to 0. Okay. Is it easier or difficult? Easier, is it? Whenever it is negative, neglect. Why we neglect? Because at x equal to 0, at x equal to 0, sorry, this term, this term is not applicable when x equal to 0. Therefore, we cancel out. And at x equal to 6, at x equal to 6, therefore, here, yeah, the sum here is positive, then we can, yeah, or we have to take into the calculation. Therefore, C1 is equal to minus 40. Okay, this is Macaulay method. Yeah. Uh, so yeah, uh, at x equal to 3, yeah, at x equal to 3 meter, yeah, because the question is, yeah, to find deflection at midspan. When x equal to 3 meter, therefore, yeah, y equal to minus 2.16 millimeter, and this is the same answer as what, yeah, we have got in using double integration, 2.116 millimeter. And what is the deflection? Uh, deflection at midspan is equal to 1.56 10 to the minus power of minus 4 radian. Very, very small deflection, because here at 3 meter, yeah, at 3 meter as at midspan. For the case of symmetrical loading, deflection, sorry, the the curve, or the slope at midspan is equal to 0. But in here, yeah, 18 meter, yeah, 18 meter is positioned at eccentric to the midspan. Therefore, it is not equal to 0, but nearly 0. Nearly 0. Yeah, you can convert radian into degree. How to convert radian into degree? Yeah, uh, you must able to do that. How to convert from radian into degree? Yeah, this is equal to what? 0.000156 radian. In degree, maybe, yeah, maybe less than 1 degree. Yeah, very small. Okay, so that's Macaulay method. Any question or any problem here? Yeah. Okay. Okay. Before we proceed with this example, I think you have been informed that the second test uh, will be on 24th. Today is 18, yeah? So 24th is Sunday. 24th of January, Sunday, maybe Sunday night, yeah, will be conducted by Dr. Yunus, Dr. Yunus, yeah, also online, 24th. And the question cover trust, yeah, trust and also uh, trust deflection and also trust post analysis and trust transformation. Okay, so it is next week, next week Sunday. So Wednesday we will have another lecture. Yeah, I hope we have time to do some revision or some example. Yeah, because time is quite limited. And I hope you can do the assignment or tutorial, which I think has been uploaded into in learning e-learning. Because I have not joined e-learning yet. Okay, and then for beam deflection, we will have assignment using Macaulay method. This method, this method, the method that we are learning now. Yeah, this will become assignment, and it is also already uploaded into e-learning, if I'm not mistaken. Yeah, if I'm not correct, then I'll ask Dr. Yunus to upload the question. Yeah, I don't know. This assignment using Macaulay method. Okay. Okay. We have another 20 minutes. Yeah. For this example 4. Yeah. We have another topic actually using unit load or virtual work method. Yeah. Maybe we can continue next lecture. Okay. Example 4. This is cantilever. Yes, sorry, a simply supported beam with cantilever or with overhanging. Determine the maximum deflection of the beam shown in figure. EI is constant. EI is constant. In this case, EI is given. When EI is given the value, then you can calculate the answer in millimeter or in radian. But if EI is constant, then your answer will be in term of EI. Okay, in term of EI. EI is rigidity. EI is rigidity of the beam or flexural rigidity. Okay. Okay. Yes. In this case, you have 8 kilonewton. You have 120 kilonewton meter moment. Bending moment at pin connection. Can you imagine how can there is bending moment at pin connection? Yeah, because at this connection, there can be some other member here, yeah, that is subjected to torsion, or there can be here, yeah, some couple of force, yeah, that introduced into bending moment. So sometimes we have to understand when you are working as engineer outside, how to idealize the condition on site, on actual building, yeah, to the ideal condition in theoretical. Okay. Uh, okay. The conditions require zero displacement at A and B. Yeah, for sure, it is very simple for us to understand that deflection at A and B is zero. What about C? At C, the deflection is maximum, but it is useless. It does not help you. Yeah? Uh, Even though we know that it is maximum, because there is no value. Yeah, it is maximum, but no value. Here, we know that the value is zero. Here, the value is zero. Value of what? Value of deflection, not value of slope. In here, the value of slope is maximum. Here is also maximum. Here, the value of slope, we do not know. Somewhere here, the value of slope is equal to zero, but we do not know where. So therefore, yeah, the information is not helping us. Okay. So the only boundary condition now is only two. Okay. The moment equation made at section X is M. What is X? Okay. Here, M equal to 8, yeah, time X minus 0 or equal to 8X plus 6 minus 10. What is this? This is the moment equation for, yeah, any point between C and A, not only between C and B. Maybe this figure, yeah, this X, this figure, this X or this arrow should be somewhere here. Yeah, again, this X should shown here. Therefore, you are here now. Yeah, remember, yeah, the principle is that you use the point X for the derivation of bending moment, where X has passed all the loading to the left. Okay, derive moment at point X where X has passed all the loading at left. In this case, is between B and A, not between C and B. Okay, that the difference between Macaulay method and double integration. In double integration method, you split into two segments, CB and BA. In Macaulay method, you derive only one equation can cover all loading. The difference is that the what you need to take note is that here in this bracket, yeah, this is called function, continuous function here. This is not the normal bracket, continuous function here. When in this bracket the sum is negative, neglect this term. Okay, when the sum of the value in this bracket is negative, neglect this term. So that means when you are here, x less than 10 meter, yeah, x less than 10 meter, this one becomes negative. Neglect this one. But when you are here, x equal to 20, for example, 20 minus 10, positive. Then you can use this term, the second term. Okay, next, yeah. I hope you can understand. Yeah, next. So this one, m is equal to ei d squared y over dx squared equal to, right, what we have derived just now. Okay, integrate, you have slope equation. Integrate again, you have deflection equation. Okay, so here, this one, there is no continuous function. So just as usual, yeah. So 8x squared divided by 2 equal to 4x squared. Now, here, okay, again, I repeat, don't, yeah, separate this one, or don't uh, bring this x out from the bracket. Okay, keep it here. And now you just integrate this bracket as one variation or variable. So x minus 10 squared divided by 2. Yeah? Squared divided by 2. So becomes 6 over 2 equal to 3 plus C1. And similar to this one, yeah, x minus 10, 3 divided by 3. 3 cancel here, x minus 10, C1x plus C2. So this equation, not only this equation, this is the most important equation. Yeah? If you derive from equation, then your answer will be wrong. Yeah, you end up with 0 marks. Now, this equation, similarly, yeah, if you got wrong answer, integration, then also will have wrong deflection. When you have wrong deflection, then in your design is wrong. When your design is wrong, then your construction will be in trouble. Will be in trouble. It will have excessive deflection or failure. Failure. Okay. Now you have two equation. Yeah. You have to you have two constant or variable, C1 and C2. That means you need to boundary condition as usual. Okay, so I don't have to explain in detail here. Yeah, what are the boundary condition? Yeah, x equals 10 meter, y equal to 0, x equal to 30 meter, y equal to 0. Okay, so therefore, uh, yeah, okay, therefore, you have C1 1333 and C2 12,000. Yeah, 12,000. Okay. Hmm. Okay. Sorry. Okay. Now C1 equal to 1333, C2 equal to 12,000. Then substitute into the equation 2 and 3. So this is the deflection equation. Therefore, yeah, to obtain the displacement of C, yeah, to obtain the displacement of C, yeah, set x equal to 0 in equation 3. Okay, that's the solution. Yeah, yc equal to 12,000 divided by ei. Okay, uh, I just want to check this one. Okay, okay. And Anybody of you notice what is the reaction RB and RA? Yeah. What is RB and RA? Because we have 120 kilonewton meter here. Yeah. I check. Yeah. 62. 62. Okay. Oh yes, correct. Yeah. This is 6 kilonewton RB and RA. Yeah. It is not shown here actually. Yeah. You can check. Yeah. You can check this reaction 6 and 2 kilonewton. Yeah. Take into your in calculation. Yeah. 120. Okay. So yes, it is correct now. Okay. So this is the answer. Yeah. This is the answer now. As you see here, in this equation, yeah, in this equation, moment is not shown here because now what we are doing is derive the equation, yeah, somewhere between C and A, yeah, between C and A. But 120 is not between B and A. Sorry, C and A. But 120 kilonewton has been considered or has been taken into calculation when we calculate the bend moment. Sorry, the reaction. Yeah. So therefore, it is considered already. So this is Macaulay method. Another example of using Macaulay method here. Okay. Sorry. Here. What time now? Okay. Another 10 minutes. Yeah. Okay. Determine the slope and deflection at x equal to 3 meter, x 3 meter. Determine the location and magnitude of maximum deflection. Okay, now reaction. Yeah, in this case, we cannot calculate the reaction based on proportion, because there are too many loading. Yeah, cannot. Yeah, my simple method cannot. So you have to use this equation. What this equation called? This is called equilibrium equation. Yeah, you have three equation: m equal to 0, fx 0, fy 0. Okay. Uh, uh, so in this case, yeah, as I said just now, we have to derive moment equation between A and B, yeah, at a point where the point has passed all the loading or has covered all the loading at left hand side. We start from here, x2, okay, pass one loading, again, pass two loading, again, pass all the loading. So your derivation should based on point in between this segment. Understand it? A point where it has passed all the loading, or a point past the last loading before the support, or before the end point. Yeah, not the support, end point. But in this case, the end point is at the support. So here, yeah, somewhere here. So that means how many term? Yeah, how many term? 1, 2, 3, 4. Yeah, make sure there are 4 loading. Yeah, there are 4 loading or 4 terms in your equation. What are the terms here? Okay. Oh yes. for this moment, okay, yeah, for this loading, okay, but for this one, for this loading, we need treatment, special treatment, yeah, uh, where you have to extend this loading, yeah, this loading up to the point where you are deriving the moment equation, and since you extend or you add with another virtual loading, then you have to cover or you have to counter with another loading in opposite direction so that it will back to original condition. Here, what is the point here is that, yeah, the x point where you are deriving the equation, all the uniformly distributed load should extend to that point, to that point. Yeah. Uh, and since it is actually just virtual, yeah, virtual, not existent, so that you have to add another, and this also extend to the point x, then it will cancel out. Yeah. Uh, therefore, yeah. Therefore, the moment is becomes here. Yeah. Okay. Sorry. This is the moment. Yeah. I cannot. Mm, mm, mm. Here. Okay. Uh, okay. Yeah. Okay. Cantik. How many? Yeah? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. Not 4. Uh, remember? 1, 2, 3. This one 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now 2x plus, yeah, 2x, this one x, yeah, plus 10 x minus 2, 10 x minus 2, x minus 2 here. Okay. But this one moment, eh? This one moment. Moment you cannot integrate. Yeah. So you put it 0. You put 0. Yeah. Uh, if it is force, you put 1. For moment, you put 0. Therefore, if you integrate, the value for the integration will be 10x minus 2. That's why you put it 0. This one, what is 2? 2 is the uniformly distributed load, but extended to the point. Therefore, x minus 4. This one is 4. And then uh, counterbalance with the upward. X minus 6, 0, 2, and so on. And this one is point load. So this is the most important equation, because based on equation, then you integrate, for slope deflection, then you integrate again to get the deflection equation. If you derive wrong equation here, then you end up with the wrong deflection equation, wrong answer. Okay. I think this is the another important point here to remember. Whenever you have UDL but short, yeah, the UDL is limited here, yeah, then you have to extend, add another virtual loading, and then you have to counterbalance, yeah, counterbalance so that it becomes equal to original condition. Okay, so this is the formula. Now, then integrate, yeah, integrate, yeah, integrate, yeah. Okay, notice here, similar to what we have done before. In this continuous function, we don't have to take out this x and 4. Integrate as a variable. Integrate as a variable. Integrate straightforward. Simple. Plus C1 and so on. Yeah. Uh, so you have C1 and C2. You see the difference here? This one is 1, but this one is 0. Yeah. So, okay. Now, how many constant? C1 and C2. That means you need to find two boundary condition. Yeah. Boundary condition here is x0, y0, x equal to what? 10 meter or what? 10 meter. Yeah. X 10 meter, y equal to 0. Therefore, C1 equal to minus 56 and what is C2? Oh, C2 is equal to 0. And then substitute C1 and C2, C2 equal to 0, C1 into the slope equation and deflection equation. Then you can calculate what is the slope and deflection at any point. At any point, but remember again, in your calculation, final calculation, whenever the sum of value in this bracket is negative, cancel, neglect. Yeah. In this case, the question is the deflection or the slope and slope at x equal to 3 meter. So 3 meter. So when x equal to 3 meter, here 3 minus 2 positive. Then you can count, count in. 3 minus 4 negative, cancel. 3 minus 6 negative, cancel. 3 minus 8 negative, cancel. Then you have only 3, 10, 3 minus 2 plus 56, minus 56, similar to y. Yeah? 3 minus 2 positive, okay, here. 3 minus 4 negative, cancel. 3 minus 6 positive, negative, cancel. 3 minus 8 negative, cancel, neglect. So you have 5, 3 minus 2, 56 multiplied by 3. Okay. Is it difficult or easy? Yeah. Just cancel, all cancel. Yeah. So it is not difficult, not difficult. Yeah. The difficulty is how to derive the first equation. The first equation. If you compare to double integration, you see double integration here. Yeah, what happened? You have to split into two segments. Yeah, if In this case, in this case, in this case, where is the question? Okay. Just okay. Just to have idea, if you use double integration, how many segment here? 1, 2, 3, 4, 5 segment. If there are 5 segments, you will have what? Yeah? You will have at least, I'm not sure, maybe 6 or 10 constant, C1 to C10 maybe. Then you need what? How many? 10 simultaneous equation. You need boundary condition, and you also need matching or compatibility condition. So this is why Macaulay method is very important for you to understand, familiar in your future works or any assignment. Okay. So it is 1 o'clock now. Time for lunch. I think I have checked your attendance. Muhammad Afiq Hilmi tak ada. Okay. Hamidul Aiman pun tak ada. Okay. Any question, or you will reserve question to Wednesday? Wednesday we will have only one topic, unit load method. Maybe it's about 1 hour. Then we have hopefully we have 1 hour for tutorial. I don't know how to do tutorial. If you are not familiar with tutorial, I can just give you more example. More example. I have a lot of example. Okay. So anyway, thank you for attendance and for your attention. Assalamualaikum warahmatullahi taala wabarakatuh. Okay. Boleh dengar lagi ni ke? Can you hear me?
Boleh.
Okay. So ada soalan-soalan boleh kumpul hari Rabu.
Okay.
Okay. We try to conduct a tutorial. I don't know how to conduct tutorial, but we try. Okay. Thank you very much. Thank you. Thanks all.